Okay, so for the electrolysis or water lab, for the introduction, so electrolysis, it's basically the process where electricity is used to make a chemical change occur in which like it wouldn't happen naturally. So in this lab, we were using electrolysis to break down like the compounds of water, H2O, 2 hydrogen, 1 oxygen, into its two elements of hydrogen and oxygen. And so we were doing this essentially by like dissolving salt, which is an electrolyte, in water and putting pencil lead through holes in the cup because graphite is actually very conductive, more conductive than we were actually attempting to use like metal paper clips. And so when you link a battery to the lead, electricity is actually able to travel through the solution and break down the water. So the electrolytes, I guess in this scenario, we use salt to create an electrical conducting solution when it was dissolved by a polar substance, like for example, water, right? Hydrogen and oxygen gas would then enter like separate test tubes facing down the cup. And so the main reason like why we did this experiment was to prove that water is like made up of 2 hydrogen and 1 oxygen. And what's it called? It was really cool because when you were actually doing the experiment, you could see that hydrogen was being released like almost twice as fast as the oxygen, which actually could play into part if you need to find out which gas is more. Because if there's twice as much of one gas, then you immediately know that's hydrogen gas because the hydrogen was being released a lot faster. So for our hypothesis, we hypothesized that if we broke down the water using salt as the electrolyte, then 2 parts of hydrogen and 1 part of oxygen could definitely be produced because like the salt was allowing the electricity to pass through the solution itself. So materials, we actually didn't use that many, but we used like a rather gradual amount. So we used like an apparatus stand basically to hold the cup containing the solution itself. We used clamps, we used beakers, salt, distilled water, batteries, wires, graphite like pencil lead. We also used test tubes. For safety notes, definitely make sure you're following the basic lab procedures and protection. So like, I don't know, if you want to wear a lab coat, that's more optional, but definitely wear goggles and gloves because you do not want to be getting any substance like in your eyes. Also, granted, like we weren't necessarily working with anything flammable, but like definitely tie your hair back. It's always just good to do that. Unpredictable stuff can happen. Also, avoid being electrocuted. Just don't let the water and like batteries come out into contact with one another because that's very bad. It ruins the batteries and you can potentially electrocute yourself. And overall, it's not that fun. When you're done conducting the experiment, definitely clean up everything there because like it just leaves it chaotic for the next group. And overall, what's it called? You're kind of just leaving all this stuff there, right? That kind of just sucks for the next group. For procedures, they're rather straightforward. First, you definitely want to follow the safety instructions. You want to gather your materials. And you want to know what you're doing. Second, insert the pencil lead like through the bottom of the cup. So we made like 2 separate little holes like for the graphite itself. And you want to make sure you have a good sized amount, but you don't want it too small or too big because if it's too small, then you can't necessarily get it in there. But if it's too big, it's going to want to slide out. So you want a good balanced, proper ratio between the 2. Third, you want to add salt to the mixture itself. 4, you should connect the tubes placed in the mixture to the battery with like the wired clamps. What's it called? Yeah, use the alligator clamps to connect them to the graphite, and then back to the to the battery circuit. 5th, you want to once your experiment, if you've like actually done your experiment, you'll know because like bubbles are formed within the mixture itself. So like with it, as our results go, like the results were that the water was, we successfully were able to break down water into hydrogen and oxygen. One test tube definitely did have like twice as much hydrogen gas as the other one. And this is good because it proved that water is made of 2 hydrogen and 1 oxygen. And the main way that we proved this was again by like the rate of which the gases were produced, right? There was twice as much hydrogen as there was oxygen. So in conclusion, our hypothesis was correct. When we broke down the water using the electrolyte salt, there was a correct ratio of gas release, and that was what we wanted from the begin with. Some more background, I guess, on why the salt was able to conduct electricity when dissolved is because the ions in the water disassociated the salt into sodium and chloride atoms. What it carried out is that the electricity through the solution was, capable of like moving throughout the solution. And furthermore, you want to use the different poles of the magnet as well, positive and negative, because they're named differently. The negative pole that pushes the electrons into the solution is known as the cathode, and the side, the side reduction. Because the ions of hydrogen and water also got reduced from the gas, the cathode is responsible for producing the hydrogen in the experiment. For the oxygen, the anode is the positive side of the magnet, and therefore it was also responsible for attracting the electrons out of the solution. So the ions of the oxygen increase to form the gas, so the anode is responsible for producing oxygen in the experiment itself. And then we also provided multiple pictures like at the bottom of our experiment as well. That you should be able to look through, as well as the presentation itself.